Okay, so here we have Winnie the Pooh. He's fallen into a hole while searching for honey, and his friend Owl is using a rope to attempt to pull Pooh straight up out of the hole. Okay, so I'm not much of an artist, so Pooh will be this little stick figure. And there he is at the bottom of the hole. And there is Owl trying to pull him out. Okay? And we want to first, A, is draw a free body diagram of Pooh in your written work. Okay? So, there's a couple key pieces of information we have here. Okay, one, he's attached to a rope and Owl is pulling up on it. So we should expect that there is an upward tension force. Let's say it's about that big. And of course, Pooh has some gravitational force on him. So that'll be, downward, some amount. And then we're saying here that Pooh the owl is unable to get Pooh off the ground. So if Pooh is still in contact with the ground, then there's going to be some amount of normal force. We don't really know how much, but it'll be, something upwards, okay? Because he's still in contact with the ground. And that's it, okay? No horizontal forces mentioned. You can imagine some friction between his feet and the ground just so to make it so he doesn't slip and fall, but these are the only important ones here. So if we look at part B, compare the normal force acting on Winnie the Pooh to the force of gravity acting on Winnie the Pooh. Okay, so the normal force, as I've drawn it, is going to be less than the force of gravity. Now, if Pooh was just standing there on the bottom of the hole, okay, just as a side note here, well, then you'd expect whatever upward normal force to be equal and opposite to the force of gravity because he's not accelerating vertically, and so those better cancel out. But in this case, Owl, via the rope, is pulling up on Pooh quite a bit, okay? And that means that he's effectively making Winnie the Pooh lighter, and so F sub n from the ground doesn't have to be as big. The other thing to note here is that Pooh is still not accelerating off the ground, right? He is unable to get off the ground. So this is our answer. So no acceleration. So net force in the y direction, so the vertical direction, still has to equal 0. F sub g doesn't change, right? It's just based on Pooh's mass. And so F sub t plus F sub n has to equal the magnitude of F sub g. So from that, we can make the conclusion that F sub n, in this case, has to be less than the force of gravity acting on Pooh. Cool? All right. And then lastly, C. Is the work done by each force acting on Pooh positive, negative, or 0? Okay, this can be explained very quickly. Well, answered very quickly. They're all 0. And the reason? No displacement, right? Owl is not succeeding in his quest to rescue Pooh from this hole in the ground. And so if you're not moving, if you're not covering ground in some direction, well, then there's no work being done, no mechanical work anyway, being done on you by any of the forces acting on you, right? The definition of work done by a particular force that we're using is this, and there is no D. All right, so that's the answer you're looking for C. Nice and simple, as long as you're thinking clearly about the definition of work, and we'll go on to another one.